Welcome to Minute Math with Mr. Monahan. Today we're going to be looking at place value revision. In your pre-assessment, if you scored a certain number incorrect, it would recommend you to this video. If we look at a number like 936, each one of these numbers represents something different. The 6 tells us we have 6 ones. The 3 tells us we have 3 tens or 31s. The 9 tells us we have 9 hundreds or 900 ones. But how do we know that? I'm sure at some point you've heard that all of our place values are based off of something called the base 10 system. And what that means is each place can only hold 10 numbers. So if we look over here at this 10 frame, we see that there are 10 boxes, and in any given box, there's always a 0. Think of this as your free space in bingo. And then it doesn't matter where you put these numbers, all the way up to 9. So if, for example, this is our 900, 0 for bingo, like the free space, then we just cross these all the way out to 9. That tells us if we were to have one more 100, this frame is full. We cannot put any more in, and we would have to go to the next one if we tried to add another 100. Then if we were to zoom in, we see that there's another 10 frame here. This is our tens place. And we said we had 36. So we cross off those ones. What this tells me is I have 6 more tens that I can add before this frame is full. And then I would have to spill over into the hundreds. We can zoom in further. And here we have our ones place. And we said we had 6. Once again, 3 more before we are full. We could zoom in even further, even though I don't have a 10 frame in here. And we could add one. And this would be our tenths place. And so you just can keep adding another set of 10 within any of these places. So let's zoom out. And talk about place value names. One thing that students tend to struggle with is they don't know you have to start here. This is the decimal point. Anything to the left is a whole number. We have ones, tens, hundreds, thousands, 10,000, 100,000, million. And we can keep adding. The next one after million, 10 million. And after that, we could have 100 million. We could have a billion after that. And this pattern of 10 billion, 100 billion repeats, and then it goes after billions, we have trillions. If we're looking at the decimal point and moving to the right, we have decimals. These could also represent fractions. We have tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. Now, even though I'm not writing this on all of them, one thing to keep in mind with these decimal values is they all end in THS. That's very different than the whole numbers. The whole numbers just end with the letter S. Now, remember those 10 frames we were looking at earlier? We made a comment that it took 10 ones to make 1 10. So 1 times 10 would give me 10. And then we said it would take 10 tens to make 100. It would take 10 hundreds to make 1,000. So 100 times 10 gives me 1,000. And these are all times 10. But that also means, when we zoomed in, I brought up tenths. So after ones, we said tenths, and it was 10 tenths to make 1. So this pattern counts on the decimal side too. Forever and ever and ever. And the reverse of that, the opposite of multiplying by 10 is dividing by 10. This tells me a couple of things. One, that a place value to the left is 10 times larger than the one on its right. And a place value to the right is 10 times smaller than the one on its left. If you have any questions, feel free to shoot me a message either on Canvas or on email. Have a great day.